I want water. You want water?
It's been the same one.
Mhm. Pardon? Yes. So not the previous one. So in this course, every exam deals with different chapters. Yes, so no, final is also not comprehensive. So final is also deal with only 3 chapters or 4 chapters, yeah, in the previous one. So every exams are all different. Pardon? Yeah, today we don't have kids because we have exam in Tuesday, so we don't have kids today. Definitely, I don't want you to do such a work. Thank you very much. Yeah. So how was the exam? Sorry. Mhm. Yeah, I understand. So next time we can use the Anurag, which it just gives you the individual proctoring. So you don't need to put it in the Zoom. Just you choose your time and place, then you can do your exam without any checking process, like this exam. So yeah, next time it will be better. And definitely, I'm very so sorry about these technical difficulties you get during the exam. Actually, I didn't expect it, but, and also, yeah, I will announce it today, but yeah, score of the exam and quiz 3 will be posted tonight, and you can check your materials or your exams in the website after all the grades are done. So please let me know if you have any question on your scores, and I promise that I will give you a very generous grade as much as possible. So don't worry too much about the grade. Yeah. Hello. Mhm. Question 17? Yeah. Yes, I got it. Yeah. No problem.
Oh, Jesus Christ. Scores will be posted tonight about Mike.
Mhm. Ah, it went through. Okay, that's why. That's one of the reasons. Yeah. But that's okay. So because you sent me emails, so I checked your emails. So I think, yeah, your grading is okay, but no problem. Yeah. Okay, howdy. So today, yeah, we will deal with chapter 5, but before going there, as I announced earlier, score of the exam will be posted tonight, and also score of the quiz 3 also will be posted tonight in eCampus. And you can see my comment on website. So please let me know if you have any question on your grade or anything else. I will accept all such your claims in before next Tuesday. So just review your exams and let me know if you have any question. And next one, so don't panic about if you did not good at this exam because each exam deals with distinct chapters. So for example, exam 1 only deals with 1 to 3, and exam 2 deals with chapter 5 and 13 and something, and so on. So also final exam is not comprehensive. So final exam is also dealing with 3 or 4 chapters. So you don't need to worry too much about you are bad at this exam. If you did the other exam better, then you can get good grades. So don't be panic or just be strong, right? Okay. Do you have any other question on exams or anything else? And lastly, I'm very sorry about what happened during the exam about this technical difficulty. That's what I didn't expect it, but so in the next time we can use the Anorak, and I already tested it, and it will because in the next exam I will give you some kind of window. So for example, you can take your exam anytime during the day, so that you can avoid such a technical difficulty like crash of the eCampus or crash of the WebAssign. So so next time it will be much more better than this exam. So again, I'm so sorry about this technical difficulty. Okay, question? Okay, great. Thank you very much. Yeah, that's good. I think also that's a good idea. Yeah. So I'm still working on what kind of departmental guideline for Anorak, but yeah, definitely it is much more better than this time. So great. Okay. So let's start. If you have any other question. Okay. Then let's start the chapter 5. So chapter 5 is all about statistics. So let's start with some definitions. So you can see some kind of data. So you heard a lot of data, kind of big data or something like that. So data, anything you scribed up into some files. So for example, there are some person and there are some their favorite lunch. For example, myself, I like the meatball as a lunch. It's a little bit heavy, but anyway. And maybe John, like, is there any other food you like? Tacos, great choice. And John loves tacos. And is there any other choice for food? Fajita, great, yeah. We have made a lot of fajita during the exam, right? So, yeah, say Jack likes fajita too. So if you see such a table, then it is actually kind of data. And so we say that in this kind of table, individual, the entities about which information data is collected. So for example, this one is also individual. This one is also individual. This one is also individual, but individuals, not only the name of people, but also it may be also groups, animals, or things. So for example, if you have some kind of data about scores of each section of the Math 167, then it will be groups of people. And if you have some data about what kind of animals, for example, what kind of cat or dog, what kind of foods cat and dog like, then you can see that animals are individual and also some kind of some things, right? So that's called individual. So each line is called individual. And a variable is a characteristic or a trait that can take on different value for different individual, right? So for example, name is definitely a variable for each individual, right? they have some different name. And also favorite runs, in this example, these are all variables of individual. So it may be either qualitative. So qualitative means that it is, maybe I like the meatball with spaghetti, but someone likes a meatball with, lasagna or something. So it is a little bit difficult to make an order or make it as a number, right? So in that case, we say that it is qualitative, gender, right? Or quantity. But sometimes your data are quantitative. So for example, if you have a data variable about age, then maybe it should be some number, right? So in that case, we says that these two data are qualitative, but this age data is called quantitative because it gives us some number. And exploratory data analysis. Oh, I need to put more words on there. Okay. Exploratory data analysis is the process of finding main features of the given data. So begin by looking at each variable and then relationship between the variables, right? So for example, maybe, some of the people has, for example, okay. So some people in the Texas likes barbecue, but some people in the California likes, what kind of food California likes? Tacos or pizzas, right? Or something like that. So you can, when you say something like that, this kind of group has this kind of characteristic, then we actually saying that the one characteristic, which is region, is related to the other characteristic, which is the food they like. So in that case, so exploratory data analysis is just give you kind of analysis that which variables are related to which variables, right? Or which characteristics are more related to which characteristics, right? So that's what we want to do from the data. And this is used for business situations. So if you're the head of the company, then you want to know what kind of customers like your brand or your product, right? So for example, if your brand are liked by the internationals, then definitely, pardon? Oh, okay. So for example, if your products are liked by internationals, then you definitely want to export your product into the world. But if your products are liked by the domestic people, then you can focus on produce your product using the factory in the America to reduce the cost. So it is very important to find out what kind of customers you have and what their characteristic is, right? So that's why we did this exploratory data analysis. Okay, so is there any question on these things? Okay, so in case of the quantitative data, there are some useful way of doing exploratory data analysis, which is called histogram. So histogram gives us some kind of graph. This is not the same as the graph we did in chapter 1, but this gives some more this kind of bar graph, right? Maybe you see in some, in the picture. So we make this data into a graph so that we can get some information about how these quantitative characteristics are there, or how many, what is the mean, or something like that, right? So this histogram of variable gives information about how often the variable takes certain values of interval or intervals of value. And sorry, this should be here. This should be distribution, sorry. Sorry about that, yeah. So distribution is about how often the variable takes certain values, and histogram is the graphical representation of distribution. Yes, that's so it is actually graphical representation of frequency distribution. So let's see some example. So we have some values 6, 7, 8, 9, 10, 11, but there are 8 of the 6 and 11 of 7 and 9 of 8 and so on, right? So for example, yeah, kind of that there are 8 people who has the number 6, and there are 11 people who has the number 11 and 7 and so on. So in that case, you can put its data into a histogram, like the people with number 6 there are 8 people who has number 6. So 2, 3, 4, 5, 6, 7, 8. So you can just have a bar whose height is 8, right? And in case of 7, there are 11 individuals who has the value 7. So 8, 9, 10, 11. So you can draw a bar with height 11. And in case of 8, there are 9 people. So, and in case of 9, there are only 5 people. And in case of 10, there are 0. And in case of 11, there are 2 counts. So you can draw your histogram as a bar. So histogram is nothing but just how many numbers are in the interval, right? So in the interval 6, then there are 8. In interval 7, there are 11, and so on, right? Okay. Do you have any questions? So in this chapter, the important thing is draw histogram from the table or data, right? So let's deal with another example. So the histogram is determined by its beam width, right? So at the first section, first example, we already give just the beam. So each value or each individual actually called beam. But let's thinking about this kind of data, right? So these are too many numbers, right? So, and then you need to determine how many beams you will use to draw a histogram. So for example, if your histogram only has only 1 beam, then it means that at the starting from 56 to 132, there are only 40 people, right? So it is interval and this is count, right? So inside of the interval from 56 to 132, there are 40 data, right? 40 numbers. So this gives you this big rectangular, right? But it doesn't give you much information about your data, right? Because yeah, the other data also keep the same thing. So you can actually take it as a 2 beams. So for example, if you just choose that if your interval is from 56 to what is the okay, 94 and 95 to 132, then one has 24 and the other has 16, right? Then it gives us this second graph in case of 2 beams, right? So now from this data, we know that at least 24 items are less than half of the interval, right? And 16 values are greater than half of the interval, greater than 95. And again, you can do it for 3 bins. So in case of 3 bins, then your interval should be 56 to 81 and 82 to 100. 100. What is? Oh, 120. Yes, sorry. 121. Yeah. And 120 to 132. So if you have this kind of interval, then one you can count is 15, 20, and 5, right? So in that case, you have these 3 bars, and it shows that actually almost all points are in the middle, but the other ones are, but still there are the numbers between 56 to 81 is more than numbers between 122 to 132, right? So if you just make your bins, if you had more bins and more bins, you can actually explain your data more subtly, right? So if you have 4 bins, then graph looks like this. If you have 6 bins, graph looks like this. 7 bins, 8 bins, and 9 bins. And for example, if you have 10 bins, 15 bins, 20 bins, then now graph looks like more softer, right? So when you have smaller bins, then it looks like this, right? So there are only 1 peak, right? So peak is the largest point in this histogram. But if you have 9 bins, now it has 2 peaks, right? Can you see it? So this bar and this bar is the biggest point in each side, and this one is the lowest point between them. So it has 2 peaks. And again, if you do it in the 10 bins, yeah, but it doesn't have, yeah, it only have 1 peaks. But again, in the 15 bins, it has 3 peaks, right? And 20 bin, it has 4 peaks. And for the other ones, there are so many peaks right here, right? So when you make your, when you just increase your bins, then data classified much more subtly. So in that case, we have such a many bins, right? So it's up to your choice to which histogram is used for exploring your data, right? So there are no canonical way to determine your bins, but you can just use all these histograms to compare your data. Yeah, to which numbers are in the which side and which numbers are in the which side, right? So these are the example of histogram. Okay, do you have any question on this example? Yeah, maybe my calculation is wrong. I think the 81 is fine, and 5, 1, 2, 3, 4, 5. Yeah, this should be 1 of 5. Thank you very much, Dawson. You're Dawson, right? Okay, great, thank you. Yeah, yeah. I just technically thinking that it should be inside of the 2/3 of the intervals, but not, it's 1 of 5, yeah. Okay. Is there any other question? Okay, so to draw your histogram, actually you can just call the computer to draw your histogram, but you need to know how to draw the histogram. So first of all, you need to choose the classes. So here classes are actually beans, right? Choose the how many numbers or how many beans you use or what kind of size you use for your bean, right? Divide the range of the data into a reasonable number of classes or weaker widths, right? And count the number of individuals in each class, and you can draw the histogram, right? So for example, let's try this example at 1.5. So this following data is recorded daily high temperature in Car Station. So we want to display this data into a histogram. So I just choose class size 5. Then first of all, it starts with 51 and ends with 56. And you know that there are only one data inside of this class. So it counts 1. And next class is 57 to, what is adding 5? 62, right? Then there are 2 data, 61 and 58 are inside of this class. So you can write down 2. And next one is 63 to 68. Okay, then you can see that actually, I used a different color. Okay. These 65, 67 are counted in this class. So you can write down 2. And the next one is 69 to 74. So in that case, press it. 69, 72, 72, 72, 73, 74, 74. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 data here. And next one is 75 to 80. So here 75 to 80 are 1, 2, 3, 4, 5, 6, 7, 8. So here are 8 data, and 81 to 86. And here are 81, 81, 82, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9, right? So there are 6 classes with size 5. Then you can write down it as here 51, 56. Yeah. Okay. And okay. Give me a second. 62, 6. I just write down all these numbers. So here 51, 56, 62, 68, 74, 80, 86. And the first one is 1, 2, 2, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. And 8 and 9, right? So you can do a histogram like this. So class size is actually given to you. So if the exam do not give you any class size, then you can just choose whatever you want. So, do you question? Mhm.
And then 56 here so that you have more room. Is that okay?
Yes, that's okay. Mhm. So what her question is that, do we have more room? So for example, you can, instead of using this short one, you can actually thinking that 51 to 56, so you can use 2 room, and 56 to 62, so you can use 2 room. Yeah, that's completely okay. Yeah. Yeah, I need to make this grid much more bigger. This. Oh, I just picked class size 5 because just choose it. So yeah, you can choose the class size 10. So for example, then you can also draw the graph as usual. But in case of, for example, okay, let's deal with class size of 10. Then first one is 51 to 60, 61, and 62 to 72, and 72 to 73 to 83, then 83 to 84 to 94. But in that case, if you count your numbers, then only first 3 are inside of the first count, and these 8 numbers are inside of the second interval, and 83 is here. 1, 2, 3, 8, 6, 9 plus 8 is 17. So 17 numbers are in the third interval, and last 3 numbers in the last interval. So what you can get is, yes, 51, 61, 17, 2, 83, 94. So first one is 3, and next one is 8, and third one is 17, and last one is again 3. So it looks like this type histogram. Yeah. So yeah, so your histogram differs which side you choose, right? Okay. Great. Okay. Do you have any question? Good. Then let's deal with second one. So now you can draw your histogram. So you need to interpret your histogram. So in case of this exploratory data analysis, those 5 questions are important. So first question is that, does the graph have 1 or more peaks? So which interval has the most data is one important question. And the other question is the graph symmetric or skewed? So symmetric means that your graph looks like here, if your mean is here. But skewed means that your graph looks like here, or your graph looks like here, right? So if your mean is, or if your middle one is here, then this one is negative skewed or skewed from to the right, to the left, and this one is skewed to the right, but I will explain it more in definition. And outliers are some data which is not fit into this main picture, right? So for example, you can see some of your data are here or here during this graph, then these are called outliers. And center are just center of the graph, and is the most data spread out or close together. So some of the data are looking like the spread it more, but some data are more concentrated at the center, right? So those are the things we want to figure out what kind of the distribution the data has. So I will explain it more clearly in definition. So first one, the symmetric. Sorry, so it's not symmetric. Yeah, distribution. As the first one, outlier is an individual value that pairs out of the poles outside of the overall pattern, such that the value seems striking deviation from the overall patterns, right? So for example, these red points are definitely deviated from the main picture, which is main big bell-shaped one. So these are called outlier. And the symmetric distribution, no, not symmetric here. It is skewed to the right. Skewed to the right distribution. So this one is, looks like here. So here is the center. So it is skewed to the right. Is a distribution in which the longer tail of the histogram is on the right side, right? And we usually, center is assumed to be 0. So sometimes this skewed to the right distribution is called positively skewed. Yes, so. Okay, and next one is skewed to the left. Skewed to the left distribution is, looks like skewed to the left, right? And again, if we assume the center is 0, then left side of the 0 are all negative values, right? So in that case, we say that it is negatively skewed. And last one is symmetric. So a symmetric distribution is one which you can see that at the center, left side are mirror of the right side, right? My picture isn't that, not that good, but you know what I mean, right? So you can see the left side is almost the same as the right side, and right side is almost the same as the left side. In that case, we say that it is symmetric, right? Okay, do you have any question on the notation or anything else? Great, then let's deal with some example and figure out what kind of the features this histogram have. So for the example 2.2 says that comments on the shape of histogram below include number of peaks, symmetry, and outliers, right? So in the first graph, if you just draw this, then it looks like there are small peaks here, but you can actually see that these almost looks like here. So in that case, we have one peak. Or you can, some of you say that actually it looks like this, so you can have two peaks, but that's up to you because it's not that clear, right? So, but in this kind of case, since these are a little bit relatively small points, so we usually say that it has one peak and symmetric and no outliers, right? because outliers should happen. If outliers were here, then it could be in this point or this point, right? But there are no such thing. Okay, do you have any question in this first example? Okay, then let's do it the second example. And in second example, this small bar is actually distant from other ones, right? And so you can see that there is an outlier. But still the graph itself, and also if this 6 is the center, right? But the graph itself is skewed to the right because almost all data are actually in the right side of the center. So in that case, you can say that it is skewed to the right. And it again, it has one peak, so it has one peak, right? Okay, do you have any question? Good, okay. And in next one, again, about the center, graph project looks like this. So you can see that it is skewed left, skewed to the left. And again, it has one peak. And you can say that this 11 has an outlier or not. So because again, we didn't introduce the exact criterion which values are outlier or which values are not outlier, right? So it will be introduced in the next chapter, but still we don't know yet. So we can say that maybe possible outlier here. Being 11. Yeah. So it will be, if you just use more beans than this 11 beans, then maybe you can figure out that whether this 11 one is outlier or not, right? But currently, given information, we don't know yet, right? Okay, do you have any other question? Good, and the next one, you can see that graph looks right. Definitely it has at least 2 peaks, right? And again, it seems that there are no outliers here because all these points in the side are related to main picture. And however, what is the middle one? So 65 is the middle one, but it is a little bit difficult to say it is symmetry because, you know, the center is here, but it is not the mirror image, right? If center is here, 75, then maybe we can say that it is symmetric, but in this kind of center, we cannot say that whether it is symmetric or not clearly, right? So maybe symmetry. If center is 75, but we don't know, right? So these are something we can say, yeah. Yeah, about the histogram. And Alexandra says that, is that third graph it's skewed right because the tail is on the right side. So, okay, let's go back to the definition. So skewed to the right is the distribution is in which the longer tail of the histogram is on the right. You're right. Thank you, Alexandra. And I'm so sorry. Yeah, I just do the wrong definition. So this is tail, and since tail is right, so we say that it's skewed right. And again, this is, in this case, tail is the wrap, so it is skewed wrap. Oh, sorry, I always had confusion about this. So yeah, so in that case, yeah, it should be skewed to the, in the second example, it should be skewed to the wrap. Yeah, and the third example, it should be skewed to the right. Oh my gosh. Yeah. Thank you, Alexandra. Okay, do you have any other question? Good. So, okay, so again, yeah, skew to the right is just tail is in the right, and skew to the left is tail is in the left. So yeah, it is not about this peak, but it is about tail. I just thinking it long, so sorry about that. And next one is about the stem plot. So stem plot is a special case of the histogram, right? So we just deal with histogram with intervals are here, and you can just make a bar in here, right? So that's the histogram. But in case of stem plot, actually we say that intervals are here, but here intervals are determined by numbers. We will see in below, and distribution bars are here, but again bars are also some number, or some numerics, right? 6, 7, something like that. So it is almost the same. So this one is called stem plot. So, and this one is histogram. So it just looks like just instead of bar, it gives us some data directly on the histogram, right? So to make your stem plot, first of all, separate your data into a stem and leaves, right? So stem is just consists of a final digit, and leaf is the final digit, right? So in this case, for example, in case of 2579, okay, so it's too many data. So let's see 11, 12, 31, 35. So in case of you have only 2-digit numbers, then this left hand side, 1, 1, 3, 3, those are stem, and the right hand side, 1, 2, 1, 5, those are leaves, right? So stem may have as many digits as needed, but leaves contains only a single digit, right? So for example, if you have these 3-digit numbers, then stems should be these first 2 digits. Those are stem. And 2, 3, 5, 7, those are leaves, right? So if this produces too many stems, then you can rounding to the data to 10 places. So that we will deal with in the last example. So But yeah, just know that you can actually, for example, if there are so many 100 things, and then you can actually round it up so that these 11, 12, 12, 12, 13 are rounded to 10, and 20 something are rounded to 20 or whatever, right? So that's the making a stem and leaf from the data. And the next, write the stems in a vertical column with the smallest at the top, and draw a vertical line at the stem of this column, right? So for example, in this kind of example, you can actually write down as 1, 3 as 2 stem, and you can write down your ribs horizontally, 1, 2, and 1, 5, right? Then that's the stem plot of these 4 elements, right? And again, in here, in this case, 11, 12, 13 are stems, and leaves are 2, 3, 5, 7, right? So again, this one is just a stem plot of this given data. Then let's deal with a little bit many examples. So display the following data in a stem plot. So here, so we deal with only 2-digit numbers. So first, you can think that actually 2579 has stem 0, 0 as a stem, and 2579 are leaves of this stem, right? And again, this one stem, and 2 stems, and 3 stems, and 4 are our stems, right? And 5 and 7. So in your table, your stem should be 0, 1, 2, 3, 4, 5, and 7, right? Oh. I need to draw it bigger. And at the 0, your ribs are 2, 5, 7, 9. And at the stem 1, your ribs are 1, 5, 6, 8, 8. 1, 5, 6, 8, 8. And at the stem 2, 3, 3, 5, 5, 8, 9, 9. And in case of 3, 4, 5, 7, 9. And in case of 4, 0, 3, 4, 5, 5. And in case of 5, it is just 7. And in case of 7, it is just 0, right? So and the reason I say that these are just nothing but histogram is that if you're just thinking about, okay, so let's copy this one. Now 2 should be 33558. 899. Oh, thank you, Joanna. Yeah, it should be 99. Yeah. Could you repeat it? you can, you need to specify stance at the red column. But, okay. Mm-hmm.
You could do, yeah, you could, don't you want us to put two, like in zero, two,
Mhm.
comma, 5, comma, 7, comma, 9 to break them up?
Uh,
Or do you not want us to put commas?
no, I don't want a comma in the split them up, right? So yeah, usually you don't need comma for split them up. And the reason why we don't need comma is that actually this is the same as the histogram, but in the other side, right? So what I mean is that if you just draw your histogram using this data and thinking about your histogram looks like this template, you can just put as a 0 to 10. Oh, sorry. Okay, okay. Just read 0 to 10 and 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, and 60 to 70. Then what you can get is first one is height 4, and second one is height 5, and third one is height 7, and third, next one from 30 to 40 is height still 4, and 40 to 50 has height 5, and 50 to 60 has height 1, and 60 to 70 height 0, and 70 to 80 height 1, right? So if you just make this histogram and rotate it in 90 degrees, then what you can get is the same as this template, right? So I just wanna rotate this. But yeah, OneNote doesn't give me to how to rotate it, but oh, yeah, it already resizing, not the rotation. Oh, here rotate, okay. Rotate right side into 90. Great. Yeah. So if you're just thinking about this rotation of histogram, then what you can get is actually Stanford, right? So Stanford is another name of the histogram with specific data, right? So it gives us not only the main picture of data, but also it gives us the what kind of data are inside, right? So that's the Stanford. Okay. Do you have any question on this example? Good. Okay, so let's deal with the next one. So round the following data to the nearest 10, then drop the ending 0 and display the result in a sample, right? So first of all, we need to round them. So 108, 18 round to 120, and 122 also rounded to 120, and 116, 116, 200, and 210, 220, and this one should be 250, 250, 270, 300, 300, 300, and 310, 320, 320, 330, 330, 330, 340, 350, 400, 410, 600, and 1000, 1110, right? So in that case, you can thinking that because all the the last digit is just 0, right? So we can just ignore them. Then you can see that our stem is the something in the first digit. First digit. Three. Six. And for the last one, since we have 1000 instead of the 100, so just 2 digits, 11 are our stems. So you can put it into stems in the column. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
You skipped 393.
Pardon?
I think you skipped 393.
93, where I...
393, 393.
393. Oh, thank you. Yeah. Definitely in the exam, I do not give such a long example for you, so don't worry about that. Because
I have a question.
Okay, question.
So on 605, would you not round that up to 610? Or would you just leave that?
610, you're right, 610.
You would?
Yes.
Okay.
It should be 610 because when we say about round the polling data to the nearest 10, 5 should be go to 10, but 4 should be go to 0.
Okay, got it.
340 where? 335 here? Oh, yes, it should be 340, yes. Thank you very much. Yeah, I promise that, yeah, I do not give such a messy example for you. 400. $401. Yeah. Mm-hmm. Yes, 390, yes. 335 should be 340, right? Okay. Okay. Okay, so this should be 330 and this should be 340. Thank you. I'm not good at math. Okay, so let's do it these calculations. So then one has leaves 2, 2, 6, 6, and 2 has leaves 0, 1, 2, 5, 5, 7. So I intentionally ignored the last digit, which is just 0, because 0 didn't give any information. So I intentionally just do not write in the stemplot. And in case of stem 3, we have 0, 0, 0, 1, 2, 2, 3, 3, 4, 5, 9. And in case of 4, 0, 1, 1. And in case of 5, there's nothing. In case of 6, we have 1. And in case of 11, we have again 1. Right, so yeah, that's our stemplot. And could you repeat your question, please? Yeah.
On this one, it jumped from 5 to 7, and there were 6, and you
yeah.
left it out.
Yeah.
these where you have the blanks left on.
Yeah, so last one is the long. So yeah. Yes, so in the last one, actually it should be 6, 7. Yeah. Okay, sorry about that. So in case of 6, there should be. Yeah, so I. Mhm. Yeah, so yeah, what is your name? Catherine? Yeah, as Catherine says, yeah, we need to have this 6 into our stem because, as I said earlier, tempura is nothing but just another name of the histogram. And in the histogram, we didn't, ignore this spot 6, right? So thank you very much, Catherine, for your help. Yeah. So again, here, yeah, we also need this 7, 8, 9, 10, even if there are no data in this class, but we need to put it on there to show that actually there are no data in that intervals, right? So thank you very much. Okay. Okay, yeah. Is there any question? So honestly, yeah, if I can make this course by myself, then I usually want you to know how to code all the data to get that tempura into your computer to avoid such a human mistake I did in this time, right? So usually, yeah, if you're interested in this exploratory search, then you can find the kind of Python code or some library which deals with this kind of thing automatically. So yeah, I will introduce it in the in eCampus. You don't need to need it, but just see it if you're interested in, right? Okay, so let's call it a day, and thank you very much. And if you have any question, please let me know. Okay. Yeah, so we don't have quiz today, so yeah, you don't need to be, yeah. Okay. Have a day to, yeah, see you Tuesday. Mm-hmm.
There should be, you only wrote 2 3s down, right? In the third one?
Yeah.
You only wrote 2 3s?
2, 3, yeah. 0001 to
0 0 1 2
I think 000
3 3 3. There should be 3 3s.
1. It should be 2, right?
2 2
Mm-hmm.
3
3. 3 3 3. Oh, yes, you're right. Thank you. Yeah.
And then the 4, there's only 2, isn't there?
Yeah, there are. Oh, yes, it should be. I think that 4 0 0 1. Yes, 0 1. Yeah, only 0 1. Thank you very much. Okay, do you have any question for people in the Zoom? Okay, otherwise I will just close the day. Thank you very much for taking this course.